How's it going, everybody? We're working on the Cat D4D again. If you watched the last video, you've already seen us press this sprocket onto this side of the machine. However, we do still need to weld that sprocket onto a hub. So this is the hub that we're gonna weld that other one onto.
Getting ready to weld this sprocket together. This is for this the right side of the machine here. Well, first of all, I got it on a flat surface. These granite tables came out of a, they're actually dressers out of a hotel. So we got a bunch of them for free. They're a good, nice flat surface. So I'm registering off of, there's a machined face on the down here, and I got it up on some 1, 2, 3 blocks. And then I have the sprocket itself on these pieces of PVC coupling that are all the same height. So everything's kind of planar, coplanar. And then I have these dividers that I can go in the gullet of each sprocket and feel to the splines and get an idea of how centered I am. So this is just a quick setup. I still have to take these back over and grind and clean up and grind in some fillets everywhere. Then once I get them grounded, you know, all the metal clean and everything, I can bring the welder over and tack some of these together. And then once it's tacked together, I'll probably take it off this table and burn it in on something else, because I'm gonna be, you know, I don't want all the spatter messing up these tables. So I might TIG this together to tack it and then bring it to a different table and then probably burn it in. I have a Miller-Matic 200 over there, which should be enough amperage to burn this in. So no stick welding. I'll probably do TIG and then MIG on top of it. So let me get this over on the sawhorses and start grinding. So I got it all ground up. I got nice shiny metal everywhere. This was torched off by the previous owner of that machine there, the second one we had. They torched the sprockets off of it. The thing, probably what I should have done too. It took longer. I used a grinder to do it. But, you know, it took a lot to de-gouge. You know, there's a lot of deep gouges across these faces, which you got to get to the bottom of. You know, remove any oxides from torching. This one is, you know, these surfaces are a little flatter as compared to a like a torched surface. So I think this will clean up a lot faster than the hub did. So let me swap to two, and I will get them both ground up and hopefully tack together, maybe. We'll see how far I get. Well, I'm out of grinding disc. That one's just about worn out. But I got enough here cleaned up where I'll just stick it on the table. I think that'll be enough to take it on. And then, like I said, I'll try to make it. If there isn't enough room, I'll probably come back in with a grinding disc after the fact and V it out with a cutting wheel. But I want to tack together first and get it, you know, I don't want to remove a whole bunch of material from both of them and then have to fill it all back in. If I can get it tacked together in the right spot, then I know exactly how much I have to V out of every piece, because they're not all uniform. Anyway, let me get it on the table. So you can see here those setup blocks I was talking about. I call them 1, 2, 3 blocks. They're really not. They're something else. They're just setup blocks. And you can see on this hub, this machine surface sits proud of anything else on the on the hub. So this machine surface can sit against that on the flat table, and then the rim is held at the right height. I've also filed and stoned this so it's flat. Any of the burrs that are on there are off. So it should be a pretty decent way to keep it flat. There we go. Sits in there just like that. And I can get this clocked correctly, and and then get it, you know, set in the right spot. You can see a spot like this. I mean, that's a 3/4 of an inch of a gap I'm gonna have to stack weld beads to get to. That's why I didn't want to go through and V all this stuff out too much, because I knew there'd be some big gaps that I'm gonna be filling. And then any of the tight ones, I can cut back more if I need to. Get you in there for a little closer look. See, that's easy 3/4 of an inch sticking around. And then some of these are tighter, right? So like this one, I'll probably have to cut back to get in there to get 100% penetration. So I'll just go through with my dividers, right? And try to feel out where the middle is. So like I can just get between, using the gullet as my reference surface, I can just get between those two, come over here this side, and the same thing, I can just get between those two. On this side, I'm way clear of any of the splines, and then over here, I'm, you know, 1/4 inch shy, so I gotta move the whole thing that way. But I'm already butted up over there, so what I'll have to do is twist it and get it to a spot where I have enough clearance. See, now that lines up pretty good. You can come back this way a little bit. And I'll just average it across the whole sprocket to try to get me a fit that I think is close enough. I mean, there's quite a bit of slop that the chains are going to be able to tolerate. So this doesn't have to be perfect, but you just want to get it fairly close. I'll go the next one over. Keep in mind, this hub has never been on this sprocket before, so you know, there's not one spot where it came off, and that's where it has to go back to. It just needs to be centered up pretty good. Look, this is getting pretty good. That's honestly, I think, as good as it needs to be. Every time I get in a gullet, I can just get the dividers into a thing. So what I'm going to do now is break out the TIG welder, tack it anywhere I can, and get it locked in that position. So now my TIG welder just blew up. I don't know what happened, but I heard I plugged it in. I had it set up over here. I was just making sure that the solenoid was working over there, and it sounded like a gunshot went off, and the fan shut off, and I think that's hooped for now. Which I'll take it apart. There might be a blown fuse or something, but that was a loud bang. So going to shut that off, and I'll have to go on to a different welder, which kind of sucks. But yeah, boy, kind of a pain. Nope. That was a good one too. I've had that welder for 10 years now. I figure I'll take this apart quick because it'd be nice to know what blew up on it. I've had this, like I said, I had this thing since probably 2015, so it's been about 10 years. I think new, this thing cost me like $600. which isn't bad for AC, DC TIG welder back in the day. Of course, they're from, you know, they're Chinese inverter things, so in all likelihood, whatever's blown up on it is has killed it. And it will probably never live again, unless it's a fuse or something. I'm assuming it was something got dirty, because it sounded like a short, and then a bang. So, we'll see. Probably my fault for running it in such a contaminated environment all the time. Let's see what we can find. I mean, there's a lot of dust in there. Yep. Right now I'm just looking for something big, something that's really blown out of it. I'm looking at all the MOSFETs. I also don't see any serviceable fuses. Well, I'll get you in here for a closer look. So you can just see how dusty everything is. I mean, everything. See the difference, the cleaned and dirty spots. So really, it's just because it's in such a terrible environment, likely. I don't see. Like you can see, there's just dirt on everything. But I'm looking for some brown staining from a blown up capacitor or a bulging capacitor. You know, like I said, these things are getting a little old for some of these components. But honestly, probably what killed it right now was the grinding dust that's in the air, because it's still got the shop door closed because it's cold out. Well, I'll give this another once over. Maybe I'll try plugging it back in, and maybe it was a, you know, that this relay may have, or not relay, surge protection may have tripped. Yeah, I just can't see anything. It's hard to tell because it's all so fucking dirty. Nope, damn. All right, you have to pardon the noise. I got a lot of, oh, there it goes, machine's off. I got a lot of stuff running. I've got the Sprocket back up here on the welding table. The TIG welder is still down at the time being, so I'm gonna burn it in with my, got a make here. It's one of the Harbor Freight ones. It's actually not too bad. But I've got it set up where I think it's okay again. You know, in terms of concentricity and everything, I think we're about as good as we have to be. So I'm just going to tack it in place and then see if I can get it up on some bearings maybe and give it a spin to figure out exactly how good I am. But I'm just going to tack it in place a couple places and see what happens. Trying to keep as much of the spatter off this table as possible. That's why I got the board over there. I don't think it's doing a great job, but it's okay. You can see some of these gaps are going to need a few passes to really burn them in there. But I just want to get it tacked for now. Oh, look at how far the weld spatter got. That's not good. It's always disconcerting. That's the other reason I'm trying to run this while I got some other jobs running out here, so that in case the thing does light on fire, I'll be out here to witness it. Go ahead and take the trash can. Yep. That can go right over here. There we go. There we go. Crisis averted. Get back to welding. My head out of there. I think that's probably tacked good enough for now. Actually, it's nice to leave your welder running. If you can, I'll just turn the gas off. Try to remind myself. If you turn your gas off and then leave your helmet on your gas, then you'll remember to turn it back on when you go to weld again. If you leave the welder running, you leave the fans cooling it. So, but that's probably good enough to self-support. There we go. And now I can get this up on some blocks or on a bearing or something and test my concentricity. I don't know where exactly I'm going to measure that, but I can hear it shrinking. Some of those gaps are pretty wide, so the weld metal is probably pulling quite a bit as it shrinks. I think that's probably good. I could probably go ahead and just burn this right in right now. But like I said, best practice to get it up on a bearing. So this is my setup. Take you out of the tripod. Here's the setup I got. It's a big deep groove ball bearing. I got one of these spacers that I use to hold the sprocket up on. That lands on the ID, the inner race, pretty well. I want to use stuff that's reasonably flat. Then on the outer race, I got these setup blocks, and I just put some studs across them. They're just sitting in there, and that keeps them from falling apart when I have it landed up on the race like that. Then that'll set against the opposing surface to this on the other side. It's nice, flat, and stoned, and that should give me something to spin on and test runout once I get an indicator on there. See, now I wonder if this thing is even going to fit in here. Oh, yeah. That should fit. I can get this closer to the edge. See, that might work, but it's just no good. It's not really that. It's not what I'm looking for at all. The issue is that it's wobbling down on that center. I got that little plastic thing that's introducing some wobble. The setup blocks themselves are splayed down, I think. It's hard to tell. I guess they're kind of sitting flat. I don't know. It's just not what I'm looking for. It's too wobbly. So, you know, I'd be tempted to just stick it right on the machine, on the splines of the machine, but getting that to rotate is such a bear because we got to go through the finals still. Even if the steering clutch is disengaged, you still got to spin up the bull gear and the pinion and all the rest of the stuff in the final drive. And doing all that just for a measurement is going to be a lot of heartache. It would be nice if my lathe was out here and my lathe was big enough to fit this. That would be nice. Well, I'll have to think about this, so hold tight. All right, I got this set up on a bearing, a different stack up. So you can see on the bottom there is a piece of magazine paper. It's actually an old calendar. And I doubled that over and then cut a hole in the middle so it's bearing just on the outer race. So imagine, you know, that piece of paper has got a hole so that the inner race is not touching the tabletop. So there's paper, then the outer race, then the inner race has a piece of paper on it with that setup block on it. And that's got it where I ran a bar across these two here with an indicator, and it's recording 0 runout across this face. I bring it out to the sprocket, and you can see we're running, I don't know what that is, total indicator movement looks like 100 thou or something like that. Yeah, 2 full rotations is 100 thou. So 100 thou is about 1/8 of an inch, which I think is too much for me. I don't mind going through, zipping these tacks off and getting that a little bit more planar. The issue is that I use these things, which I thought were going to be good enough, and they probably would have been. They measure very close, this and those two couplings over there. They measure very close. The issue that I ran into is this surface, I didn't realize, has a bunch of casting marks on it and stuff like that. The serial numbers engraved in there, or not engraved, but embossed on there. And this surface just isn't very flat. This surface is very flat. So what I'm going to have to do is flip it over and use this surface as a reference and this surface as a reference. And I'll probably end up, instead of using these things, I will find out wherever wherever this sits, I'll shim this up, and what I'll do is mill 3 blocks to be exactly the same height, and do it that way. I thought this was going to be close enough, but they're just not. These aren't consistent enough, and the surface on the bottom that I was registering off of isn't flat enough. So I really want to register off this face, which is a lot smoother and is a lot more flat. So that's my plan. I'm going to go ahead, get this stoned down well, and then cut all these tacks off. Alright, that's off. I can go bring it over the table and get it set up again. The thing's cut back off again. It's been like a week. And I got the dividers back out. The sprocket's upside down from what I had it welded last time, so now I'm indexing off this bottom face. I'm indexing off of the face opposite of this with a setup block. And I'm just going around with the dividers and trying to get a good medium before I get my first tack on. Happy with that. I'm going to tack right there first. At this point, I'm only going to go with 3 tacks, I think. Try to get a little influence. Then once I get this tacked up and I'm happy with it, I'll run the indicator, and after that I'll go outside and burn it in. I got some 7018s. Actually, a guy commented on the last video about what rod to use, so that's the one I'm going to go with. So I'll get you back on when I'm indicating in. Alright, so I got it welded on the rest of the way. I'm going to close this door because it's windy. I'm going to stick this piece of paper on the granite. Then I'm going to stick this bearing on it, and that will, the outer race of the bearing will land on the paper, and it'll give me enough clearance to allow the inner race to float. Then the inner race, I'll again shim with this piece of paper. Then I'll put a setup block on top of that, and put the sprocket on top of that. First is the paper. Get this out of here. Bunch of weld spatter and grinding grit. So allows that to still spin. This will go on. Yeah, I'll try to center up as best I can. So that can spin freely. And now I have to get this sprocket to fall down on here. Just like that. And now I have a reasonably stable thing to indicate off of. First thing I'll have to do is run an indicator on that face to verify that I'm running reasonably true. Then I might bump it in on this diameter and get everything set squarely. So I got 2 thou runout there. It isn't terrible. Let me try to bump it in. I don't know if I'm going to be able to do this very easily. Oh. Okay, it's like 5 or 10 thou, which is as good as that setup's going to allow me to measure. Then facially, yeah, we're talking still in like that couple thou range, which is good. That face is all sorts of up, which is no good. So I'll try to get a measurement down here. Got a big piece of steel just to stick the magnet to. So every rotation of that dial, every full rotation is 50 thousandths, because it's 25 to the bottom and then 25 around again. And it looks like we're getting around 50 thousandths. It's not particularly flat. You can tell just by the way the dial's moving. It's not moving smoothly. It kind of sits in one spot for a while and then goes around to another spot, which means that it's not super flat. But within 50 thou everywhere, I'm calling good enough. Especially considering this is a worn gear, or a worn sprocket rather. And I don't really have a good way of determining concentricity with the hub, aside from just using those dividers, because I don't really trust anything in this area. There's no way for me to run it onto the gullets, and even if I could, those are all worn. The teeth are not going to give me any real information. So I'm going to call that good enough. I'd imagine in the field they do this with tape measures, so I think we're good, well on our way. What I might go back and do is tack a couple more spots, just to make sure it's good and solid before I move it over onto this welding cart and burn it in with some 7018s. So, all right, I got the welder is down under here. It's an old, really old buzz box. I got it set at 200 amps with a I think it's a 5/30 seconds electrode. 5/30 seconds, 7018. I got the sprocket here on the table. And because it's 7018, it's supposed to be a low hydrogen rods you're supposed to bake beforehand. So I got one of these cheap rod heaters. So that's where I'll be grabbing all my sticks from. They're in there. I think they're like 300 degrees right now. I've never welded with this stuff before. So we'll see. I actually did a couple test welds. I did a couple test welds on that piece of metal over there. And it kind of starts really hard, which I'm attributing to the welder and maybe the rod, but I'll do a couple tests. I'll try to fill in some of the big gaps here and see how that goes. I think I might be pulling other welds apart. not terrible. You might be asking yourself, why didn't you just MIG it all? And that's because, well, I can explain oh, I should really cover that seal up or something. MIG has the negative side of MIG is the workpiece, which means that it's pulling electrons from the workpiece into the wire of the MIG nozzle, and then it's just spattering molten metal onto your workpiece. Where stick is electrode negative, so the electrode has the electrons and it's shooting them like a cannon into the workpiece, and it gives you deeper penetration at the same amperage. So it's better for thicker, bigger pieces of metal. I'm going to keep bouncing around here and see how much I can get on there. I need to cover that up. Alright, I finally went around and I got every spoke on this side pretty much all the way across. This one took forever. This had probably a 3/4 inch gap on it. So just getting that to build up sideways like that was kind of a pain. I probably should have stood it up on end and welded from the top and just let it connect. But I'll go ahead and flip it and see how much penetration I got. I'll probably have to do this all again on the other side. So let me flip it quick. Not great, not terrible. You can see how much built up on that one, right? All that falling down. But stuff like this, that's V'd out nicely for me, so I can just lay a bead in there, and it's connected on the bottom, so I should be able to do that pretty easily. Even stuff like this with a kind of a narrower gap, I think I'll be able to burn that in. let it sink in to the other weld and get 100%. So I'll probably clean it up a little bit with a grinder and then just have at it. Started raining out a bit, so I took it inside onto this cart, and I went ahead and finished out all the welds. They're not great. Some of them are better than others. Some of them are uglier than sin. So, you know, overall it's attached. So I'm happy with that. I got to go ahead and get this cleaned up again, and then the seals on, and then I can go ahead and stick it back on the machine. And then hopefully I can get the track frames in here through this door. So, yeah. Here's pressing on the other sprocket. I should have got this on video because a catastrophic failure. Yeah, I think I was looking at the gauge. I was sitting over there looking at the gauge, 5,000 or so psi, and yeah, loud pop. But let me do the math. That might be enough to just measure it and leave it at that. I might also just put on another cylinder and go the other way, because this side blew out with that chamfer on the bottom. This side doesn't have that chamfer, and it's a little thicker wall on the top where the O-ring sits, or where the ridge sits for this the deck. But boy, that's catastrophic. So let me stick another one on and see what happens. Yep. All right. I figure I'll get this one on camera if it blows up again. But like I said, this time I'm going to go with the thick part facing towards the jack, and hopefully that'll keep it in compression. I'm thinking what happened is the jack was cocked a little bit and got into that chamfer and spread that apart. Kind of scary. It's all right. Safety squints engaged.
Oh my god.
Just trying to get that centered up on the jack nice. Now I'm gonna get it back under pressure. And go over here. Go get it. 45 degrees is what they say. $5,000, $5,500, $6,000, going up to 62. That's 6,200. It's creeping down a little bit. I wanted to stabilize at 62. Although this pump could have a leak in it. Feel good about that. So that's about 23 tons. I've got all the stuff for that side together. So I'm just gonna go through, everything's cleaned up nice. And I'll go through and kind of assemble stuff. This is the race for the bearing is already in there. I got the bearing up here where it's nice and clean. The race we didn't change, so that's going to stay there. There's a slot there that indexes with a pin on the inside of there. You can see the pin down on that side. And all of that's in line with the key. And this is a very tight sliding fit, so you really have to get it lined up just right. Let's see. That just slides in and out of there, just like that. So with these parts assembled, there's now a groove right there that's formed between the threads in this piece, and there's an O-ring that sits right in that groove. So I'll go ahead and get some silicone O-ring lube. all the way around this just to keep it clean. It also helps, you know, silicone won't break down the material the O-ring's made out of, Luna N nitrile. It'll help it stay in shape longer. Typically what causes O-rings to deform is heat, and this won't see much of it because it's just the rear end, so that should stay good for a while. Then on this big castellated nut, this is where the other seal rides, and it also is what adjusts how far inside this housing the bearing race is, right? As you tighten this, it pulls these threads out of the carrier and will tighten the bearing preload on the rear end. This side has the aluminums, they call this the ramp, that fits the floating ring with its rubber gasket. This one came out, so I'm just putting a fresh O-ring on there. It has the same silicone that the other one does. It'll just stretch the O-ring over. Right. And it just presses on there, easy. And then this whole thing will go on those threads. I got motor oil here. I'll just distribute some motor oil across all these. Just a light oil, so I don't run into any, just to help keep moisture off of there and all that, you know, and to pre-lube everything, so nothing's causing me any issues. That started on that. I want to make sure to get all the oil that just got all over this thing. There's all sorts of oil and lubricant on this ramp now. That's not supposed to be on there. These are supposed to be assembled dry. This surface here on the floating ring and the surface here are supposed to pinch this thing when it's dry. Everything's supposed to be super dry. I don't know why that is, but that's what the book calls out, and they're pretty deliberate about making sure it's not contaminated with oil and stuff like that until it's in service. You know, once it's in service, this is going to see oil on one side, but when it's assembled, it's supposed to be assembled dry. So go ahead and clean out all the oil. And then the only way I found to get these things in there is you got to take a screwdriver and just work it in. The book prohibits this. I found no other way of actually getting these things to interface. So screwdriver it is. And just don't get greedy, you know. Small bites the whole way around until it starts sitting flush. I'll just go around and make sure. I don't think you can go too far in because eventually those ramps will start fighting each other. So really you just want to make sure everything's even. I'll go around with my thumb and feel the gap everywhere. And where the gap's higher, I'll adjust some stuff, get it floating nice and even. that's good. Okay, now that's assembled, ready to go on. Before I can do that, I need to get my, most importantly, the washer. Because the lock washer goes on before the nut does, because we've already messed that up on one side. So I'll get that lock washer on there, then the nut, then your bearing will get heated and shrunk onto the shaft. So let me go ahead and get set up for that. I've got this cleaned up pretty good. I did not take this seal out of the sprocket, but I'm just going to leave it as is. Just make sure the face is cleaned up good. All of these surfaces are smooth, burr-free, and as clean as possible. I'm going to go through and make sure the threads are clean, which I've already wire brushed this and Scotch-Brighted everything nicely. But the first thing to go on is the lock washer. This is a used one, which is probably should have been replaced, but it's okay. And then I'll just oil up the threads of the nut here. And this nut will get placed and torqued to, I believe it's 400 foot-pounds or something like that. I don't have a, just like the other side, I don't have a torque wrench that goes that high. So I'm just gonna stand on this bar if I can get this thread to start. There we go. Okay. I'm about 200 pounds, so standing on the end of a 2-foot bar is your 400 foot-pounds, and a little bit of jump overcomes any stiction, and I call that torqued. I gotta go ahead and bend over the locks. Go, and then this will tend to rotate that way. That one lines up good. We'll get a punch in there. There we go, locked on. The next tricky part is just making sure the bearing gets nice and hot and slides on. You really want to check for burrs on the chamfer here. If it sticks, it'll shrink on there and you're going to have a hell of a time getting it off again. So just a light filing on that chamfer. Now let's heat up the bearing and stick it on. All right, I got the bearing shrunk on there. The next thing to go on is the whole bearing holder assembly that we just put together. There's a key that goes in there on the dead axle. It's already in place, and this will just slide on over top of everything. Make sure everything's as dust-free as possible. And see. There we go. That's as far as it's going to go right now. This washer goes on just as a spacer for now. Then I can get this nut on here. I want to get these seals preloaded and then go ahead and get the bearings set up where they're supposed to be. There's a procedure in the book I'll have to follow to do that. Somewhere I have the right socket for that. It's this one. Yep. So that would be tightening this nut, which is pulling the outer race of the bearing towards the dead axle. I'm going to continue to do that until it tightens up a little bit. Because we're probably way off in terms of where the bearing preload is on this side. See how much I can still move that sprocket back and forth. Means that that nut is not pulling up there. Let me think. There's a chance I'm supposed to wait to do that. Let me read the book. I'm way out of my element right now. All right, this is the track frame piece. I don't know, this goes on top of the bearing holder. And this O-ring fits on this groove and is retained by this piece here. And I was confused because this faces inward to the machine, so there's no access to these screws after the fact. And this O-ring's too small to fit in that groove. So I was wondering how to assemble it, but it turns out the gap that's formed between this piece of sheet metal and that bronze bushing is small enough that you jam the O-ring in there and then the whole thing gets slid onto the carrier. So I'll go ahead and assemble it. What I first am gonna do is get some grease just all around here to help seal out any moisture that might find its way in there. I put a coat of grease everywhere. That'll be my first line of defense for dirt or whatever from migrating. So that plops on there. There's a bunch of countersunk screws. Oop, it's on upside down. Bunch of countersunk screws. And each of these was peened, I'm assuming from the factory to keep from rotating out. It also could have been like a farmer that owned the thing. You'll see once I snug all these down that the gap formed is small enough to capture that O-ring and make it so I can assemble it off the machine and slide it on. All these screws came out pretty easy, so I'm just gonna get them down, as tight as I can, just with the screwdriver. I'm not gonna reef on them or anything, or use a punch. And the O-ring will just get pushed in that gap like that. Typically O-rings fit in their own free floating groove, which is why this seems strange to me, but it's the only way that I'm going to be able to assemble it. So I'll go ahead and get it pushed in there. Hopefully it does its job of sealing. I can get some grease on. There's a bronze bushing in there that is the original one. I did not change. It has Zerks to grease it from. One there. There's another one somewhere else, I believe. But for now, I'll just get a light coating of grease on that and then go ahead and stick it on the machine. There we go. That feels good. Not binding anywhere. I'm gonna wait to install a rock guard that goes on top. This rock guard goes over like that, but I need access to adjust the bearings still, so that'll wait. And I'm not gonna put any shims on this piece yet until I get the track frame in here and I can do an actual alignment. So that might be the next step, actually. Yes. All right, I got the track frame in here. I went through and cleaned up. This is the bearing cap for the cross arm, they call it in the book there. This cap goes on here and sandwiches a pin. Well, it's actually the other side of the dead axle underneath the rear end. And then this cutout sits right here. These two pins here and here sit here and here on the carrier. So I cleaned all that up. I just wire brushed that and ran a file across around these pins and inside of those bores. I'm just gonna slide the track frame in, get this one bolted on, and I'll do the same thing on the other side. be enough to hold it. There you go. And then I got to track frame's held on there now. The spacing of the track frame on the machine in this direction is dictated by a pack of shims that go between this plate and the rest of that hub carrier. So you have to take this nut off, take this plate off, and then stack shims until you get everything aligned properly. I'll do that later. I only have a few bolts in this side. But that's the track frame on, so do the same thing on the other side, and then I'll get ready to do some adjustments. Bearing preload. So basically the order of operations is get the thing on there, which is step one is done. Then you have to adjust your shim pack, get this nut torqued again, and again that determines axial play of the whole track frame. Then once this is tightened, you can tighten your final drive bearings, because if you try to tighten this up before this nut is tight, you'll just push the whole thing off, right? This has to be tight because this is bearing against this nut effectively. So hopefully any of that was on camera. What was I pointing to? Okay, I could see that. Yeah. And then once that's on, all the covers can go on, the rock guards and stuff like that. And then we just got to string the tracks on it, hopefully. So this side, the track adjuster, we never took the track adjuster out of this side. I think we're just going to run it. It has broken springs, and the track adjuster is still in the side. The other side, we took it out. We'll probably rebuild that one and probably put it back together with the broken springs still. Run the tracks until they're loose, you know, until they break all the rust off them. Then we can go back in, change the springs, and rebuild this track adjuster. I think we'll do that. That's how that'll go.
But that's going to be for the next video. Hope you enjoyed this one. Thanks for watching, and we'll see you next time.